This video is a part of my project testing airliner models, how near real they are. As criterion I chose the behavior of the JAR A320 during takeoff without extended flaps, and on the second takeoff with full flaps on a runway with average length. Concerning takeoff with full flaps, increased flap angle increases drag, reduces acceleration, and so reduces the climb gradient for a given aircraft mass, and increases the takeoff distance. There are aircraft that are not certified for full flap takeoffs, and in some cases, that additional drag might in fact reduce the performance so badly that the takeoff run will be extended. As a certification requirement, all planes must be able to climb from sea level at max gross weight with full flaps deployed in standard day conditions. Taking off at full flaps is well within airliner capability, depending on how heavily it is loaded, how high the airfield is, how long the runway is, how hot the temperature is, and how steep the required climb gradient is given the surrounding terrain.
Rotate. Gear up. Speed check, flaps 3. Speed check, flaps 2.
Takeoff without flaps is possible. The Airbus A300 and Boeing 767 are approved for such takeoffs, and it is being done regularly. It results in a better climb gradient, especially with one engine. Generally seen, as far as commercial airplanes are concerned, each is certified for takeoff with one or more flap settings. To be technically correct, at that correct flap setting, the pilots can ensure that for that day's takeoff, at that airport at that time with that weight, the runway lengths requirements defined in the FAA-approved airplane flight manual are satisfied. To protect against incorrect flap setting during takeoff, every commercial aircraft has a takeoff warning system. This system looks at aircraft on ground signals, flap position, and throttle positions, and as soon as the throttle is advanced toward takeoff power, sounds a loud warning horn if the flap setting is the incorrect one for takeoff.